Dear learner, I welcome you all to the massive open online course on emerging technologies in renewable energy. I am Sanjay Agarwal, Professor and Pro Vice Chancellor of Chhattisgarh Swami Vivekanand Technical University. Dear learner, in this session, we are going to discuss various applications of solar photovoltaic technology, construction and working of the solar lantern, solar street light, solar community light and solar PV system for drinking water. As you know, the solar photovoltaic technologies is employed for directly converting solar energy into electrical energy. The most widely used technology is the silicon solar cell. The electricity generated by the solar cell can be used for different applications directly or through battery storage system. Solar PV has found wide application in the rural areas for various important activities beside the rural home lighting, remote village deprived of grid powered using the solar photovoltaic technologies. The economics of rural electrification can be attractive considering the high cost of power transmission, transmission losses, electric power supply in rural areas, scattered population in remote and far-flung areas. Now we will discuss the different solar photovoltaic technology, and under this category, first of all, we are going to discuss about the solar lantern. The solar lantern is a portable lighting system. It is easy to carry around and therefore ideal for the both indoor and outdoor uses. A solar lantern is usually meant to provide light for 3 to 4 hours daily. If we talk about the solar lantern, so a typical solar lantern consists the following component like a PV module of roughly 8 watt peak to the 10 watt peak capacity, a sealed maintenance free battery of 12 volt and 7 ampere hour, a compact fluorescent lamp that can be considered as a CFL of 5 watt or the 7 watt rating. Here you can see the typical solar lantern in the diagram. Here you can see the CFL, then you can see the solar photovoltaic module, and the bottom part it has the battery where electrical energy will be stored during the sunshine hour. Now we will explain operation of the solar lantern. A solar lantern is a simple application of solar photovoltaic technology which has found good acceptance in the rural regions where the power supply is irregular and scarce. Solar lantern is a compact and portable and hence need no installation. The PV module is placed in the sun during the day and is connected through a cable to the lantern unit. The incident solar radiation is converted into electricity which in turn charges the battery indicated by the green LED light, and at night the battery provides power to the lamp. The cost of solar lantern lies in the range of rupees 3000 to 3300. The low cost model for the solar PV modules and battery capacity are also available. Now we will discuss about the solar street lighting system. A solar street lighting system is an outdoor lighting unit used to illuminate a street or an open area, usually in villages. A CFL is fixed inside the luminaire which is mounted on a pole. The PV module is placed at the top of the pole and a battery is placed in a box at the base of the pole. The module is mounted facing south so that it receives solar radiation throughout the day without any shadow falling on it. A solar street lighting system is provided with the battery storage backup sufficient to operate the light for 10 to 11 hours daily. The system is provided with the automatic on-off time switch for the dusk to dawn operation and overcharge, or you can say the deep discharge prevention cut off with LED indicators. Here you can see the typical solar street lighting. Here you can see the lamp connected, the battery storage which is placed in the bottom of the pole, The solar street light system consists of the following component. First one is a 74 watt peak solar PV module, then 12 volt 75 ampere hour tubular plate battery with the battery box, then charge controller cum inverter, then 11 watt CFL lamp with the fixture, and 7-meter mild steel lamp post above the ground level with weatherproof. Again, because there is some hardware is also required, like mounting wire is required, and paint is also required to paint the pole, so that to avoid the rusting and all that due to the weather condition. Now we will discuss about the solar home lighting system. Solar home lighting system are used for lighting and other uses whenever is required. These systems are useful in non-electrified rural areas and as reliable emergency lighting system for important domestic, small commercial and industrial application. It is also possible to run a small DC fan for 12 volt DC television with the system. However, for the domestic applications like heating of the homes or water, where large amount of power is needed, PV based system may not be economical. For such application, solar thermal systems which collects the heat directly from sunlight are preferable. The system consists of many components. That component can be discussed one by one. Like first component of for the solar home lighting system is solar PV module, or you can say the solar cells, as we have already explained that solar PV module is nothing, it is an interconnection of different solar cell. Then the second main component of this solar home lighting system is charge controller to avoid the overcharging. Third component is a battery. Basically battery is nothing, it is a combination of the cells, and this battery is used to store the electrical energy during the sunshine hour, and this stored energy can be used during the off sunshine hour, or you can say during the night time. Another component for such system is required lighting system, that may be classified as a lamps and fan. That means it will depend how many lamps are required and fan are required, and this number of lamp and fan will be dependent on the how much capacity of the PV modules are installed. The solar module is installed in the open on roof, or you can say terrace, exposed to the sunlight, and the charge controller and battery are kept inside a protected place in the house. The solar module requires periodic dusting for the effective performance, because when dust is formed on the PV module, that means it will obstruct the solar radiation which is coming from the sun to the PV modules. That means efficiency will get down. So removing the dust continuously is a requirement for to get the better performance. Now we will discuss a typical solar home lighting system, which has first component, that is a PV module. It may be of the 18 watt or maybe of the 36 watt or 75 watt capacity. Then another component that is required for typical solar home lighting system is a sealed, maintenance free or flooded lead acid battery of the 12 volt or 20 or 40 or 75 ampere hour capacity. It depends on how much power is required to operate the CFL, or you can say fan. Then because we are talking about the solar home lighting system, that means CFL is also required. This CFL may be of the rating of the 9 watt or the 11 watt, it depends. So solar home lighting system are designed to give a daily working time you can say of 3 to 4 hours with a full charge battery. The system provides for buffer storage for 1 to 2 noon sunny, or you can say cloudy days, when the system may be generating electricity with reduced efficiency, since the intensity of the sunlight on such day is only 10% of the total intensity of the sunlight. So we have already discussed, that means solar intensity is a very important parameter to get the better electrical output, because The whatever the electrical energy that you are getting from the PV module, it depends on the solar radiation. It will also depends on the ambient temperature. So typically we say that you will get the maximum electrical efficiency at the ideal standard test condition. And what are those standard test condition? That means if intensity is 1000 watt per meter square and ambient temperature is 25 degrees centigrade. The cost of an solar lighting system depends on the load, the capacity of the PV modules used to meet the load requirement, and the capacity of the battery to meet the required backup. The indicative cost of different solar home lighting system modules are listed here. Here you can see module 1 like 19 watt CFL lamp. The cost of this particular system will be roughly you can say rupees 6,000. If we talk about the model 2 which has 9 watt CFL lamp, so it will cost around rupees 10,000. If we talk about the model 3 that has 9 watt CFL lamp and one fan, this fan may be of the you can say 30 watt or of the 40 watt. So overall cost for this type of model 3 will be the rupees 11,000. If we talk about the model 4 which has 9 watt CFL lamp and fan, as well as you can operate the television, that means the cost for such type of system will come roughly 18,500. So this cost depends on the many factors. This cost may be vary, it change time to time, it depends on the year, it depends on the technologies, it depends on the brand also. Now we will discuss about solar PV water pumping system. So here you can see in the diagram, the solar PV water pumping system is a standalone. The power generated by solar cells is used for operating DC surface centrifugal monoblock pump set for lifting water from bore, or you can say the open well or water pond for the minor irrigation and the drinking water purpose. The schematic diagram of this solar PV water pump system is shown here. You can see the solar PV module and then pump, and there is a charge controller also, PV modules are there. So as we have already discussed that again because this pump is being operated by the solar PV modules, and this solar PV module generate the electricity. This electricity will be provided to the pump which will run this pump, and this will pump the water from the ground. That means how much water you can take from the pump, it will depends on the capacity of the pump, and if capacity of the pump is required, that means electrical energy required is more. That means electrical power, whatever the electrical power is required, it will come from the PV module. That means what will be the capacity of the PV module, it will depend on the capacity of the pump also. So this system consists of the many component like because we are talking about this solar PV pump. So this typical component of solar PV pump is 1800 watts solar PV panel. Roughly we can say if one PV module is of 75 watt, that means 24 number of PV modules are required. Now another component, or you can say the main component, that is a 2 horsepower centrifugal DC monoblock or AC submersible pump is required. Then inverter is also required, because suppose this pump is AC pump, that means whatever the power is being generated from the solar PV module, that means there is a DC power. So this DC power can be converted into AC by the inverter, that means inverter is also required. The average water delivery of 2 horsepower solar pump will be around 1.38 to 1.40 lakh liter per day for suction head of 6 meter. The size of suction and delivery lines is 2.5 inch, or you can say 62.5 mm. So solar pump has many advantages, like for running this pump no fuel is required, because whatever the fuel is required, that is the sun. That means, and what that energy is free, because as you know, solar energy is free. That's why we are saying that no fuel is required. Second is no conventional grid electricity is required. That means water pump that is being run, which is operated by the solar PV, that means it does not depend on the grid electricity. So we can say another advantage is no conventional grid electricity is required. Then third advantage of this one is long operational life. Next one is highly reliable and durable, and the maintenance is very less, easy to operate and maintain, eco-friendly and pollution free, because pump is operated by the solar power. That means whatever the fuel that is you going to use, that is just sun energy, so that you are not using any electrical energy, you are not using the diesel. That means the solar PV water pump is the pollution free. Another advantage is saving of the conventional fuel used in the water pump. That means you are not going to use any conventional fuel, as we already discussed. That means you are not using the diesel, you are not using the electrical energy, because whatever the electrical energy that you are using, that electrical energy either coming from the thermal power plant, and to run this thermal power plant again coal is required. That means we are not using any conventional fuel. So you can say saving of the conventional fuel if you are going to use the solar water pump. Now we will discuss about the rooftop solar photovoltaic system. As you know, the Ministry of New and Renewable Energy, Government of India, has recently announced a scheme of rooftop solar photovoltaic system for reducing energy consumption in commercial establishment, institution, government building, shopping malls, hotels, hospitals, nursing homes, industry and housing complex facing power shortage during daytime. The benefit of this scheme is, first one is estimated payback time period. The benefit of this scheme is estimated payback period is in the range of 5 to 6 hours. That means whatever the cost you are putting to make such system, after the 5 to 6 year, the overall cost, you can say it will be free. That means after the 5 to 6 year, the whatever the energy that you are going to generate, it is free. Second advantage, or you can say benefit of this scheme is life of the system is about 20 to 25 years. So as we said that estimated payback period is 5 to 6 years, that means remaining, if we are considering that life is 20 years, that means remaining 15 years, whatever the energy you are generating from this system, you are getting the free energy. Third advantage is no air and no noise pollution. Other advantage of such system is no moving part and the little maintenance is required, because in case of the solar PV rooftop system, no moving part are required. That means no motor is there, no rotor is required. That means nothing is moving. If nothing is moving, that means there is no noise, so no pollution. Again, advantage is a 100 kilowatt peak capacity rooftop solar PV system could save up to 50,000 liter of diesel in a year. So you can imagine how much saving can be done by such system. Now we will discuss solar powered traffic signal system. The conventional system can be replaced by the solar powered traffic signaling system, which use LED and work without interruption during the power failures. LED based light last much longer than conventional filament based lamp. Hence, routine maintenance cost would be reduced. The design of this system depends on the number of lights to be operated at a junction. A photovoltaic array of about 1 kilowatt peak capacity would be required for 4 road junction along with an appropriately sized battery bank based on the site condition. This system does not require an inverter. In case of needy, the system can also work with conventional grid supply. The system features include auto, on off and blink switch also. The cost of solar powered lighting system depends on its component, including PV array, battery bank and electronic controller. For 4 road junction, the cost would be about rupees 6.4 lakhs. Such systems are presently being used in the Bangalore, Delhi and other major cities in the country as per the data provided by Ministry of New and Renewable Energy annual reports. Now we will discuss solar photovoltaic based information display system. So LED based information display system powered by solar photovoltaic are now being installed at road junction or on the roofs of the prominent building and the other places. This system are slowly replacing traditional neon tube based system. The latter are not only expensive but also consume more energy. Such solar photovoltaic powered display system can be installed in the urban areas and along highways. And for a typical LED information system of size about around 1 into 2 meter and consuming about 300 watt of energy and solar photovoltaic module of about 2 kilowatt peak capacity is required to enable it to operate all throughout the night. For 300 watt system requiring 15 hours of operation, the approximate cost can be about rupees 7 lakhs. Now again we will discuss the solar PV power system. The photovoltaic power generation unit may be standalone for the supplying power to the scattered load in the areas where it is difficult to take grid connected power. The output of solar PV system is DC. So for AC load, DC power may be converted to the AC power by using inverter. A photovoltaic array consists of several solar cells interconnected in series or in parallel combination. A solar photovoltaic system need very little maintenance since only the cleaning of the glass cover of PV module is required. Rain may do this job, but these can also be washed. However, batteries may need proper care to perform at their maximum efficiency and to last longer. So here you can see the solar photovoltaic system for the DC load. A complete design process for solar photovoltaic system is beyond the scope of this particular topic. However, we will give the salient feature of the design process for you to understand the whole process. So first step you can understand, the first step is to know the conversion efficiency of the photovoltaic cell array, and this may be explained by the particular formula. So efficiency can be written as E upon A H tau, where this eta A is denoting as a PV cell efficiency and this capital E is denoting electrical energy produced by the photovoltaic cell or module, or you can say array, and this capital A is denoting the area of the PV module. This capital H is denoting solar radiation per unit area on the PV cell array, and this H is generally also denoted by the I, which is denoted as a intensity, but in this formula this intensity is denoted by the capital H, and here you can see the another term, that is a tau. So this tau is the thing, it denotes the transmissivity of the PV cell array cover. The second step you can understand here. The second step is to calculate the electrical energy output of the PV cell array. The electrical energy output of PV cell array is the difference between the absorbed solar radiation and the energy lost to the environment. So you can say the electrical energy output of PV cell array is equal to the absorbed solar radiation minus energy lost to the environment. So absorbed solar radiation is what? It can be written as A multiplied by capital H multiplied by tau and alpha, and energy lost to the environment can be written as A multiplied by U multiplied by Tc minus Ta. This Tc minus Ta is basically, you can say, the temperature difference. And so in this formula, because you know what is A, what is H, what is tau. So what is alpha? Alpha is nothing, it is a basically absorptivity of the cell, and this EU is nothing, it can be said as overall loss coefficient of the array, and it is calculated or denoted in watt per meter square, and this Tc is a solar cell temperature and this Ta is ambient air temperature. Now we will understand what are the third step. The third step is to calculate the daily electrical energy produced average over a month by the PV cell array, and this can be written as E is equal to A tau H eta, and this E is a monthly average daily electrical energy produced by the PV cell array, H is a monthly average daily irradiance per unit area on the cell surface, and eta is monthly average array efficiency, and this can be denoted as eta is equal to ratio of integration of eta H dt to the integration H dt. Next step is estimate the efficiency of this control system, that is a battery, inverter, etc. Let it be the eta C. So the monthly average daily electrical energy available to the load can be written as EL is equal to eta C E. Now we will understand whatever we have discussed by giving one example. So for 1 meter square solar cell array, some data are given, and the array is used to supply a constant load of 20 watt, and the efficiency of the power condition system is 95%, and this H is given as 15 megajoule per meter square per day. The average cell efficiency is 0.12. The transmissivity is given as 0.97. You have to determine the monthly average daily array output and monthly average daily electrical energy available. So just you know the formula, E is equal to what? A tau H eta. So just you have to put all the value. So here you can see area is given as a 1 meter square. This tau is given as 0.97, and H is given 15 into 10 to the power 6, and the efficiency is given as 0.12. So just you have to put all the value and solve it, and the value is coming 485 watt hour. So the monthly average daily electrical energy available may be calculated by this formula, eta T is equal to eta EE. So just put the value, eta C is given as 0.95, E you have already calculated, that is 485. So 485 multiplied by 0.95, it comes 460 watt hour. Now we will discuss solar PV system for the lift irrigation. Solar photovoltaic power generation system for lift irrigation depends upon the suction head and the water requirement. So you can see the many options given in this particular table. So the characteristic are for the clear sunny day and when solar panels are fitted toward the south to get the maximum solar radiation. So here you can see that if water requirement is 3000 to 30,000 to 40,000 liter per day and suction head it is a 5 meter, that means you required 300 watt panel are required. Similarly, you can go through this particular table and accordingly you can decide the PV characteristic, that means how much rating of the PV modules are required. So at present capital investment in solar panel is roughly rupees 15 to 18 crore per megawatt, 4 times that of thermal at rupees 4 to 5 crore per megawatt. The cost is expected to reduce by half and efficiency double when nanotechnology is integrated in solar cell in about in coming years. A solar project comprising 9,000 crystalline typical solar modules of 230 watt each has been commissioned in 2009 in the West Bengal. The plant will generate 3 million units of electricity a year, enough to light 2000 rural or 500 urban household. The facility will save 7 lakh ton carbon dioxide emission a day, that is as much CO2 as 2 megawatt thermal power project emit daily. The power that solar plant will generate will be fed into the grid for distribution to the customer in the Asansol Ranigad belt. So dear learner, solar photovoltaic technology is employed for directly converting solar energy to electrical energy. Solar photovoltaic has found wide application in rural areas for the various important areas. Remote village deprived of grid power can be easily powered using the solar photovoltaic technologies. The economics of the rural electrification can be attractive considering the high cost of power transmission and erratic power supply in the rural areas. A solar lantern is a simple application of solar PV technologies which has found good acceptance in rural areas where the power supply is irregular and scarce. The solar lantern is made of three main components: solar PV panel, storage battery and lamp. Solar street light system is designed for the outdoor application in unelectrified remote rural areas and is an ideal application for campus and village street lighting. Solar home system is powered by solar energy using solar cells that convert solar energy directly to electricity. The electricity is stored in the batteries and used for the purpose of lighting and other domestic application wherever required. The solar home system is fixed installation designed for domestic applications. Solar water pumping system is a standalone system operating on power generated using solar PV system. Solar PV pump has many advantages like no fuel cost because it uses freely available sunlight, no conventional grid electricity required, long operating life, highly reliable and durable free performance, easy to operate and maintain, eco-friendly and leads to saving of the conventional diesel fuel. So dear learner, in this particular session we discussed various application of the solar photovoltaic technologies, and under this solar PV technologies we have discussed briefly the construction and working of the solar lantern, solar street light, solar community light and solar PV system for the drinking water. Thank you very much.